Imagine the very last photograph a spacecraft would take before diving forever into the black expanse between the stars. Not a close-up of a planet, not the frozen surface of a moon, but our entire solar system portrayed from the outside, from a vantage point no human-made object had ever occupied. That is exactly what Voyager 1 handed us, and that single image would quietly, permanently change the way we see our own address in the universe. Long before their signals shrank to almost nothing, long before their instruments were switched off one by one to preserve every remaining drop of power, the two Voyager probes set aside one final gesture for humanity. It was not cold scientific data. It was something dangerously close to a goodbye. These would be the last photographs their electronic eyes would ever capture. After them, there would never be light again. After sweeping past the gas giants and overturning everything we believed we knew about the outer planets, the spacecraft did something no one had ever dared to try. Following a request that sounded more like poetry than engineering, it slowly turned its camera in the direction opposite its destination. It aimed back toward the place it had come from. It was a delicate, almost reckless maneuver, attempted at a distance where no spacecraft had ever risked such a thing. In a series of 60 captures, Voyager assembled a portrait of our small cosmic neighborhood, seen from an angle no human being has ever held. That image became legendary. But the still photograph, frozen in time, hides far more than it reveals. Every fragile point of light scattered across that mosaic holds an entire planet. Worlds the Voyagers themselves visited up close in brief and unforgettable encounters, before moving on. In this video, we're going to use each of those points as a door. We'll recover the final images, stabilize them, restore the motion that time erased, and step through each pixel back to the moment Voyager stood face to face with that planet. We'll travel back in time alongside these ships and relive the journey that carried them here. Get ready to see the solar system in a way you have almost certainly never seen it. To grasp the magnitude of what happened, we need to mark a date, February 14th, 1990. On that day, Voyager 1 was already drifting roughly 6 billion kilometers from Earth, a distance the human mind simply was not built to process. By then, the sun had stopped being the golden disk that warms our mornings. Shrunk by the distance, it was nothing more than an intense star, a single point of light nailed to the black wall of space. There was an enormous technical problem. Voyager's cameras were never built for this task. They were designed to record the violent storms in the atmospheres of giant planets, to capture the finest detail at close range. No one designed them to photograph tiny, nearly extinguished specks of light lost in the sun's aggressive glare. It was like asking a long-range telescope to spot a single firefly on the other side of a fully lit city. That is when Carl Sagan entered the story. The astronomer championed an idea that many considered, at best, too romantic to be worth the effort. What if, for the first time, we took a photograph of the solar system looking from the outside in? What if we could finally see ourselves from far away? The proposal met resistance. Several engineers feared for the equipment. Pointing such sensitive sensors in a direction so close to the sun could burn them out permanently, ending part of the mission in one stroke. There was also a practical obstacle. At that distance, the planets were scattered across an enormous arc of sky and shone faintly, nearly transparent from how dim they were. The risk was real, the reward uncertain. But Sagan saw something the calculations couldn't show. He knew this was one of those opportunities. An entire civilization gets only once. Once the ship moved on, we would never again be in that position. The moment would pass, and it would not return. NASA gave in. After warming the sensors for hours to protect them from the brutal cold of deep space, Voyager began its final choreography. It slowly rotated its wide-angle and narrow-angle cameras and fired 60 times, sweeping the sky piece by piece. What it sent back was at once breathtaking and profoundly humbling. Venus appeared as a pale crescent, Jupiter and Saturn gleamed like beacons, and right in the middle, the Sun, transformed into a lonely sentinel. Now all that remained was to discover what hid behind each of those points. Let's begin with the most distant and most timid point in the entire portrait. Neptune appears as a bluish smudge, so faint it almost dissolves into the black background, and for good reason. It is a planet so remote that sunlight takes about 4 hours to reach it. That was the only time Voyager 1 caught Neptune at all, and even then only in passing, like a stranger glimpsed from very far away. Its twin, however, had a far closer encounter. On August 25, 1989, Voyager 2 tore through space just 4,950 kilometers above the planet's clouds. It was the most intimate dive ever made into that forgotten corner of the solar system, and what it found defied everything anyone expected of a place so cold and so distant from any source of heat. Here on Earth, we treat hurricanes as nearly uncontrollable forces. Neptune makes our fiercest storms look like a late afternoon breeze. It hosts the fastest winds ever measured anywhere in the solar system, gusts that reach a staggering 2,400 kilometers per hour. Stop and think about that. A planet so far from the sun that it barely receives its warmth, and yet it seethes with energy, driven by internal mechanisms we still don't fully understand. Most people only know Neptune through the finished colorized images released decades ago. But when we go back to the raw data, to the original frames we recovered and stabilized for this video, something rawer and more alive appears. You can make out the shadows cast by high clouds over the deeper layers of the atmosphere. Dark bands sliding past, colossal storm systems turning in absolute silence. That faint little smudge in the family portrait is not a dead planet. It is a frozen, furious cauldron full of secrets we have barely begun to decode. And there is a detail that carries a melancholy weight. Since that flyby more than 3 decades ago, no other emissary of ours has ever returned. That was the last human look cast so close, and nearly everything we know about this blue giant still comes, in large part, from that single, lightning-fast encounter. The rest is still waiting in the dark for a ship we haven't even built yet. Following the camera's motion inward through the system, we find another pale smudge, Uranus. Like Neptune, it appears in the portrait only as a distant blur. And like Neptune, it was never visited up close by Voyager 1. That honor again fell to Voyager 2, which passed by it in January 1986. For many years, Uranus carried an unfair reputation. It was nicknamed the most boring planet in the solar system. The images from the time showed a smooth sphere, a uniform blue-green with no visible storms, no dramatic bands, nothing to hold the eye. It looked like a billiard ball suspended in space, a planet with no personality at all. But the images you're seeing now, reprocessed and restored to motion, tell a different version of the story. The culprit was never the planet. The culprit was the timing of the visit. Uranus has one of the strangest features in our entire neighborhood. It spins essentially lying on its side. Its tilt is roughly 98 degrees, as if something in the distant past knocked it over and it never got back up. When Voyager 2 passed through, one of its poles was pointing almost directly at the sun. Uranus was living through a kind of extreme summer, a seasonal lull in which its atmosphere seemed to be asleep. The ship arrived at the wrong moment and photographed a giant at rest. Decades later, Far more powerful telescopes, both on the ground and in orbit, caught the truth. Uranus is, in reality, intensely active. Its seasons are long and brutal, and every seasonal turn awakens violent storms that tear across its atmosphere. What Voyager saw was only the sleeping side of a planet that spends much of its orbit in a fury. So the next time you look at that discrete blur in the family portrait, remember what it hides. Not a monotonous planet, but perhaps the most bizarre of all our neighbors. A world that rolls sideways around the sun, with seasons that last decades, a crooked and misaligned magnetic field, and an origin story so violent it still puzzles scientists. Far from being the dullest, Uranus may be the most misunderstood member of the entire family, and we still hadn't reached the two planets both ships came to know up close. Now the camera carries us to the brightest point in the whole mosaic, Saturn. Unlike the ice giants, which were visited by a single probe, Saturn had the company of both ships. Voyager 1 arrived first in 1980, and Voyager 2 followed in its footsteps the next year in 1981. It was one of the most celebrated chapters of the entire mission. But behind this encounter lies a dramatic choice few people know about. One that shaped the course of all space exploration. Saturn became a critical decision point. The scientists faced a cruel dilemma. Voyager 1's trajectory could be adjusted in two completely different ways, and only one of them would be possible. On one side, the chance to press on toward Pluto, the last unexplored world, a frontier never reached. On the other, Titan. Titan, Saturn's largest moon, was an enigma wrapped in a thick orange atmosphere so dense it completely hid its surface. The temptation to get close was irresistible, and it was Titan that won the contest. By diving toward that mysterious moon, Voyager 1 paid a steep price. Titan's gravity flung the ship upward, out of the plane where the planets orbit, ending for good any possibility of reaching Pluto. The trade, however, was worth every penny. That detour gave us the first real glimpse of a place with rivers and lakes of liquid methane, eerily similar to the early Earth, hidden beneath a golden haze. And then there are the rings. Both ships revealed Saturn's rings with a richness of detail no one had imagined. Where before we saw only a few soft arcs, they showed thousands of distinct strands of ice and rock, waves and spirals, all held in balance by gravitational choreography of almost impossible precision. It was like opening a watch and finding 1,000 gears where you expected just one. That is why looking at Saturn reduced to a simple bright point in the final portrait carries a particular melancholy. After admiring every detail of that jewel suspended in space, finding it turned into a single isolated spark lays bare the true scale of the universe. But if Saturn stunned us with its beauty, the next planet stunned us with the sheer impossible. The camera's sweep continues toward the center, and we find a sharp, steady white point, Jupiter. When the Voyagers arrived there in 1979, they didn't merely record a planet. They set off an earthquake in the scientific community. No one was prepared for what appeared in the images. Watching Io, one of Jupiter's great moons, scientists noticed something that contradicted every expectation. Active volcanoes. Enormous plumes of sulfur were being launched hundreds of kilometers high, escaping the surface and tracing delicate arcs against the black background. It was the first time humanity had ever witnessed active volcanism on another body in the solar system. In an instant, Io went from being an inert rock to being the most geologically violent place we knew, a moon in constant eruption, stretched and kneaded by the colossal gravity of the giant planet. And then there was the storm. The great red spot, that furious eye that has churned in Jupiter's atmosphere for centuries, was captured in spectacular detail. It is a cyclone so vast that the entire Earth would fit inside it with room to spare. In the images we reprocessed for this video, you can follow the whirlpool turning, the currents of cloud winding around that ancient vortex, a weather machine that refuses to die. Jupiter was, in many ways, the place where the Voyagers proved their worth. There, it became clear that these machines were not simple flying cameras, but explorers capable of revealing the unimaginable. Every new image toppled an entire textbook. The solar system, which had seemed reasonably understood, revealed itself to be strange, dynamic, and full of surprises. And that is precisely the lesson that makes the next point so unsettling. After coming face to face with alien volcanoes, storms larger than planets, and rings of infinite complexity, the camera turned toward the center of everything, toward the star that holds every one of those worlds in place. And it showed us just how small that star is too. In the final mosaic, the sun presents itself as a single intense, sharp-edged point of light, just one more glow surrounded by darkness. It is the only photograph of our star ever taken from so far away, well beyond the orbit of the main planets. At nearly 6 billion kilometers, that source of all the life that ever existed and ever will on Earth is nothing more than a lonely spark. It is hard to accept, but there is the proof. The star that governs our days, our seasons, and our very existence, seen from a great enough distance, is just one more tiny point among countless others. And surrounded by that glow lies the point that gives the entire mission its meaning. A minuscule bluish grain suspended inside a beam of sunlight scattered by the camera's own lens. It is Earth. Neither Voyager 1 nor Voyager 2 came home after they departed in 1977. They pressed on, always onward, without ever looking back. But there, in 1990, Voyager 1 made a single exception. Years earlier, while still relatively close, it had already captured Earth and the Moon together in the same frame, from about 11 million kilometers away. Now, though, the distance was on another order entirely. Now the whole planet shrank to less than a pixel. It was before this image that Carl Sagan spoke the words that would become eternal. He invited us to look again at that little point and to understand what it meant. On that grain of light live every king and every beggar, every love and every war, every person you have ever loved and every person who has ever existed, all of human history, with its glory and its pain playing out on a particle suspended in a beam of sun. There is nowhere to call for help. There is, at least for now, no other place for us to go. That little point is everything. Soon after composing this sequence, Voyager's cameras were switched off forever. It was not a failure. It was a conscious and serene decision, made to conserve power so that the instruments able to sense the plasma and magnetic fields of interstellar space could keep working for longer. From that instant on, the two ships became blind travelers, feeling their way through the total darkness between the stars. Today, they are still going. They carry with them the golden record, a time capsule holding sounds, greetings, and images of our civilization, in the improbable hope that someday, somewhere, someone will find them and know that we existed. The family portrait was a daughter's last look toward home before setting out on a journey with no return. The Voyagers may be the purest proof of human curiosity. They went farther than anyone predicted and still send us whispers of data nearly 5 decades on. That blue point works like a mirror. It shows how small we are and at the same time how far we are able to reach. If the vastness of the cosmos and the courage of these small machines have moved you, join us on this journey. Leave a like. It helps the channel enormously to keep creating deep content like this. Subscribe and turn on the bell so you don't miss our next voyages through time and space. And tell us in the comments, what do you feel when you see Earth reduced to a single point in the immensity? Thank you for walking with us to the very edge of the solar system. We'll see you at the next frontier.